So nature is crazy. Go back a couple 100 million years and you'll find animals that by today's standards break all the rules. Animals that looked like fish but couldn't breathe in water, reptiles that gave birth to live young instead of laying eggs, creatures the size of giraffes that could fly. When we started discovering fossils of animals like these hundreds of years ago, we lumped them together in our textbooks. By the mid-1800s, we had a word for them: dinosaurs, Greek for terrible lizards. And for a long time, anything that was weird and extinct and vaguely reptilian was called a dinosaur, even though scientists were finding they actually weren't that closely related to each other. We don't classify organisms by how they look or how they behave. By that logic, bats and birds would be in the same group. Instead, we organize them by their evolutionary relationships. And scientists have been teasing out those relationships for centuries by studying the only evidence we have left for dinosaurs: their bones. What we're finding out is that a lot of the creatures that people still call dinosaurs are not that closely related to each other. They're actually not that closely related to dinosaurs. Today, we know that the true extinct dinosaurs were technically reptilian in that they laid eggs and lived on land. Beyond that, paleontologists identify dinosaurs by looking for specific skeletal traits, particularly in their heads and their legs. In the head, all dinosaurs have 4 distinct holes in their skull bones, 2 little windows on each side of their faces, right behind the eye. Those holes allow dinosaurs' skulls to grow larger without getting too much heavier, and made possible the big, powerful jaws that many became known for. Animals with these skull holes are called diapsids, meaning 2 arches, and they include many of today's reptiles as well as birds. Now, check out the legs. Most reptiles, like alligators and lizards, walk with their legs out to the sides. Their thigh bones run parallel to the ground, and they move by scuttling forward. Dinosaurs' legs did not do that. They had hips that allowed their legs to go directly out from under their bodies, so they walked with upright limbs below them, just like modern birds continue to do. Once you put all these things together, it becomes a little easier to figure out who the dinosaurs were and who they weren't. For instance, one of the more infamous dinosaur imposters is Dimetrodon, a genus of distinctive reptilian-looking animals that lived about 300 million years ago. Going by appearances, these guys generally fit the exotic popular conception of dinosaurs: giant lizards with fearsome teeth and freaky sails erupting from their backs. Like if they came in to read for Jurassic Park 5, they would probably get the part. But Dimetrodon lived hundreds of millions of years before dinosaurs came on the scene, and even though they looked like giant hunchbacked iguanas, they're actually more closely related to us than they are to dinosaurs. Yup! Dimetrodon is an important but lesser-known character in our family tree. They're sometimes described as mammal-like reptiles, but they're not true reptiles, even though they laid eggs and were mostly scaly. Instead, they're synapsids. Unlike diapsids, with the 2 skull holes on each side, synapsids have only 1 little window just behind each eye socket. And you have one too, right here, above where your jaw hinges. That's because you, and all of the other mammals alive today, are the only living synapsids. Critters like Dimetrodon are the distant evolutionary ancestors of us, and in fact, its flamboyant back sail thing is actually one of the earliest signs of their connection to us. Paleontologists think it was a fleshy flap full of blood vessels that allowed it to regulate its body temperature, something truly cold-blooded reptiles could never do. And look at how it stands. Its legs are out there on the side like a crocodile, not underneath like a T-Rex or a Stegosaurus. Alright then, what about the pterosaurs? They could fly, and birds can fly, so pterosaurs must be some kind of dinosaur, right? Nope. Pterosaurs were reptiles that just happened to arrive at the same mode of travel that birds, bats, yellow jackets, and lots of other animals did: flight. Named winged lizards in Greek, pterosaurs ruled the skies from 230 to 66 million years ago, and we can tell from their hollow bones and their musculature that they really could fly. The earlier and more primitive or basal pterosaurs found in the fossil record had long tails that probably helped them with this